Thank you all for coming. I'm really excited to be talking about AI and research assistants in the social sciences. I was really happy to be working on this topic in particular because I'm one of those people who run a lab on campus, the Urban Politics Lab, and I take on a bunch of RAs, both at the undergraduate and graduate level, and trying to think through the implications this has as large language models become more readily available, how it's changing at least my and a bunch of people's approach to how they do research assistance. Next slide. So largely AI can be a really effective research assistant. It can be this good research support that we can all be using. In particular, I list out a couple really good tasks that AI can do quite effectively, whether that's first pass on code and scripting, whether that's data cleaning and formatting, or doing the more boilerplate administrative tasks. And the big thing with these tasks, the common thread is that they are well defined. You have some well defined input, and you can catch errors where they occur. This is one of those tasks that you actually would probably give a research assistant just starting out. I remember when I first came here and thinking through IRB and like submitting documentation. Like I have the draft of projects, I have the notes, and I usually hire an RA to try to put everything together and give me the first draft of the IRB submission. So this is an administrative task, but it's also really important that someone starting out on the research process, they should be able to do this. But a big thing to remember as AI starts to kind of take on some of these roles, AI doesn't know your field's norms. AI doesn't know what good looks like. And AI is pretty good at having confidently produce plausibly looking text and ideas, right? So this is just one of those things you have to keep in mind as you're using AI as an efficient research RA. Next slide. And when thinking about some of the uses of where I were previously using an RA that I ended up using a large language model, I do a bunch of survey experiments. And I started over the last few years, when I was asking the dependent variable questions, I always ask the respondents to do one or two sentences, just letting me know why they chose that response. So at the end of the process, I've drafted out the paper, I have their numerical responses, I have it in a nice table, and then I would normally go and ask a research assistant to read my paper. I give them data with these open-ended responses, and would ask my RA to kind of place some of these responses in the paper somewhere, right? Giving life to the results. And here, you can ask Gemini to do this quite effectively, and it works out quite well, right? Again, when we're thinking about putting together some resources on how to use AI as a research assistant and the broader implications, a thing that you should be noticing is that it has the potential to replace a lot of RA work and thinking about what are the broader implications of this. It's particularly important when we think about these coding related tasks. So Claude Code right now is extremely good at doing most, if not all, coding, as long as you give it the right methodological norms. Next slide. So I want to talk a little bit about this personal experiment I did, and it will give you a sense of RAs, the human version versus the AI version. So let's say I wrote a paper, and I have the messy first draft of code. I tend to be a pretty messy, like minimal comment person when I am first writing code. It's just how it is. I'm going to get better with time. I gave it to Claude Code and I said, can you read my draft of the paper, look at my messy code, and output the clean version of the code that's well commented and reproduces the table, and make sure you catch any coding errors or mistakes I've made. This is something that I would have given to a graduate research assistant. It's to that level where I think a graduate student would be able to read a paper, see the tables I put, and can analyze and critique messy code that I have written. And the large language model does quite well at it. It refined the code, it replaced things that were mistakes, it told me the responses. But again, this is using large language models as this replacement to RA-ship. Okay, so that's one area where I like gave it messy code and it did well. Now, what if I just gave it my draft paper and the database without the code. And I asked it to run the analysis as you see fit. Well, it does all of the mistakes that a untrained research assistant would make. The first thing I noticed in the code was an na.omit. It dropped a third of my responses. It was just a bad idea, right? And like that's something that you could catch with research assistants and something that you should be able to catch when you start working with large language models. So a big lesson in this is that AI can make the same mistakes as an untrained research assistant. And if you don't give it the methodological norms, just like you were investing in a research assistant, they will invent their own and make the same exact mistakes. That being said, we have this potential to move towards large language models largely because it can accelerate this work. Where an RA would take a week or 2 weeks to do something, the large language model takes less than 10 minutes. And that's the challenge when thinking about the broader implications of incorporating large language models, at least as research assistants in this field, and why we should be thinking about these broader implications. Next slide. So the catch is AI requires the same level of investment that you would give to a human research assistant that you need to be giving to the computer, right? You still have to give very clean and clear tasks. You still have to teach the person or the computer these methodological norms. You still need to review and give feedback, and you always have to verify the output. So the big question is, why are researchers, professors moving more towards research assistants who are large language models and not humans? Again, in the survey that we did, about 17% said that they were using it to replace RA work. Next slide. And this is the big problem. This is the pipeline problem. And it happens to both undergraduates and graduate RAs. As we move more towards large language models, we're actually leaving people out. We're actually messing up this pipeline problem. So let me give you two examples. One, you have a very entrepreneurial undergraduate who comes to your office and says, yes, I want to be your research assistant. Normally in my lab, we take on 2 to 3 of these a semester. And I noticed in myself last semester, I only had one because I was starting to use large language models more. Now, what's the problem with this? As I would normally give an undergraduate a easy coding task or to do some transcription or to do a very preliminary literature review search, these kind of entry level jobs or tasks, they are no longer getting that experience because I'm going to try to prioritize either productivity gains or efficiency gains. So what happens is that there's this path not taken, that these small tasks are not there to build expertise and to kind of cultivate this burgeoning like intellectual curiosity. And I, as someone who deeply cares about the mentorship process at both the undergraduate and graduate level, I think this is going to end up being a really bad problem. So now take what happens to the graduate student. Okay. Graduate students in my lab would typically be doing some larger coding tasks, as in writing replication memos on papers or annotation or drafting large memos, telling me where the gaps in the literature are. All of these things actually build expertise in them and also makes them better researchers in the end, right? And if we're all just moving towards large language models, we're actually, again, having this path not taken. We're not treating this as a apprenticeship model as we should because we're doing it less and less often. So we're actually messing up this pipeline as we turn intellectually curious undergraduates into the potential graduate students of the future. And then for the graduate students, we're slowing down the process of apprenticeship because we're no longer using them in this learning process. And so it's going to slow down them becoming independent researchers. So as we start to use large language models more and more as research assistants, yes, they can be done quite efficiently and effectively. And one of the positive things about it is that undergraduate or graduate student is not going to graduate, right? So like humans will graduate and move on, and then you have to train you have to train the next crop of students. But I'm going to say we should still do that because we care about the mentorship process and the apprenticeship process because we care about the next generation of scholars. So again, the fear is the fear is to not mess up this pipeline. Offloading tasks to large language models cuts off the entry and progression points for our students. Next slide. So here is just my pitch to you to not skip the human RAs. Yes, incorporate research assistants as large language models. Absolutely. They can do really good AI first passes. I do this all the time now. Let an AI maybe clean some code or do some initial searches, but also keep a human research assistant because it's really good and important for skill building. So even if an AI is faster, the RA needs the experience. And that's just on these smaller administrative tasks. On the substantive tasks, when it comes to analysis and writing and actual decision making, yes, you as the professor need to lead, but you actually have this opportunity to actually have an apprenticeship model where the RA truly becomes a researcher and they're going to co-design something with you. And that's something that I want to make sure we're not missing as we have this huge progression in artificial intelligence. So again, yes, we can use large language models, but also be mindful about how often you're pushing things off to AI and not using humans. And one last thing I want to say about this is that large language models have this homogenizing effect. Computer scientists will maybe call this model collapse. We see it a lot in AI writing that you're starting to see the same exact sentence structure over and over again. We do not want that to happen in science because that is going to slow down scientific innovation. Humans give that variance that we all need. And one way you can capitalize on that variance is hiring a human research assistant and having conversations with them so you can co-design with that research assistant. And that will be much better for the scientific progress. Thank you.